So today we can see cycloconverters for the lab class. So cycloconverters means it will convert AC input voltage at one frequency to AC output voltage at other frequency. That is, it will convert the frequency of the input voltage to another frequency, and we can also change the magnitude in a single stage conversion. So here we can change both the voltage as well as frequency. So it will convert input power at one frequency to output power at a different frequency, and it's a single stage conversion. Voltage as well as frequency can be controlled. So this will be the difference between cycloconverters and the voltage controllers. So there are two types, that is step down cycloconverters and step up cycloconverters. So here step up, step down depends upon the frequencies. That is, if output frequency is less than input supply frequency, it will be step down, and output frequency greater than the supply frequency, it means it will be step up cycloconverters. So the applications are speed control of high power AC drives, induction heating, static VR generation, and mainly it is used in aircraft and shipboards for different speed applications. So if you vary the frequency, means we will obtain different speeds in the different parts of the aircrafts and shipboards. So the types of cycloconverters are depends upon the configurations and supply voltage. First one, we can have the single phase to single phase cycloconverters. So in that we are having step up and step down, and in each step up and step down we will have midpoint and bridge type SCRs. Midpoint configuration means it will be 4 SCRs, and bridge type configuration means it will be 8 SCRs. And similarly for the step up cycloconverters. Then next one, three phase half wave cycloconverters. That is, three phase to three phase have 6 SCRs, and three phase to three phase converters cycloconverters will have 18 SCRs. And three phase bridge circuits, that is three phase to three phase cycloconverter with the isolated load phase of 6 SCRs, and three phase to three phase cycloconverters with non-isolated load phase of 36 SCRs. So this will be the cycloconverter, the basic center tapped or midpoint configuration circuit. So here we are having 4 SCRs, P1, N1, P2, N2. So here P1, P2 are positive group, and P2, N1, N2 are the negative group. So we for every cycle of the input voltage, we have to obtain positive output, means we have to trigger either P1 or P2. If we require negative of cycle at the output, means either we have to trigger N1 or N2. So for positive of cycle, so this terminal A will be positive and the terminal B will be negative. So we'll have two choices. Either we can trigger this positive will be applied to the anode of P1, and this negative will be applied to the cathode of N2. We have two choices, P1 and N2. If we trigger P1, the output will be in a positive side, and if we trigger N2, the output will be in negative side. Suppose we require positive side output, means so we have to trigger P1, so the current will flows from A to O. So next one, we can also try for N2 triggering. So if we trigger N2, means so this will be positive and the current will flows in this direction. So here the current direction will be in opposite to that of the previous case. So this will be the positive direction. So positive, here negative, and this will be a negative direction. That is, from here it will be positive and this will be negative. So here we can obtain the positive and negative cycles. Similarly for negative cycle, A will be negative and B will be positive. So for this case, this negative will be applied to the cathode of N1 and this positive will be applied to the anode of P2. So for triggering of P2, the current direction will be like this, that is from A to O. And if we trigger N1, means so the current direction will be like this, that is the opposite side of the previous case. So for obtaining positive side output, we have to trigger any one of the positive group of SCR. For obtaining negative side of the output, that is negative half cycle of the output, we have to trigger any one of the negative group of SCR depending upon the input positive and negative half cycle. So if we are having positive half cycle at the input, means we have to trigger the positive P1 or P1 for positive output. If we are having negative half cycle at the input, means so we have to trigger N1 or P2, and P2 triggering will gives positive at the output and N1 triggering will gives negative at the output. So P1, P2 positive group, and positive group means if we trigger these groups, the output will be positive, V0 will be positive, and if we trigger negative group, means the V0 will be negative. V naught will be negative means we will get negative half cycle. Similarly, for bridge type, we will have 4 SCRs P1, P2, P3, P4 for positive and N1 to N4 for negative. So we can go for different. First, we can see the step down cycloconverters. So we can go for different frequencies. So here we are having supply frequency 50 hertz and output frequency 25 hertz. So the time period TS will be 1 by 50. That is 1 by 50 will be 20 milliseconds. So 1 by 50 will be TS will be 20 milliseconds and T naught will be 1 by 25. 1 by 25 will be your T naught. So the T naught will be 1 by 25 will be 40 milliseconds. So 40 milliseconds will be the time period of the output. So 40 milliseconds means positive half cycle will be 20 milliseconds and negative half cycle will be 20 milliseconds. So here, so this will be your 0, 10 milliseconds, 20, 30 and 40. So for 0 to 10, the combinations, that is the thyristors that will be in forward bias are P1, P1, N2, right? P1, N2, and here it will be P2, N1, and again it will be P1, N2. So here it will be P2, N1. So these are the forward bias thyristors for positive half cycle. For positive half cycle of the input voltage, the forward bias thyristor are P1, N2. For negative half cycle of the input voltage, the forward bias thyristor are P2 and N1. So we have to obtain 0 to 20 milliseconds for positive half cycle. So we have to trigger positive group. So for first half cycles at 0 to 10 milliseconds, we have to trigger P1, and 10 to 20 milliseconds also we have to obtain the positive half cycle. So that is we have to trigger the again the positive group, that is P2. The next for obtaining negative half cycle in the output voltage. So this will be your output voltage. So this will be your supply voltage. So for obtaining negative half cycle in the output voltage, so here the choices are P1 and N2. We have to obtain negative, so that we have to trigger N2. So next one 30 to 40 milliseconds. The choices are P2 and N1. So we have to obtain negative. That is, we have to trigger the negative group N1. So P1, P2, N2, N1. So P1, P2, this will be totally 20 milliseconds positive half cycle. P1 will conduct for 10 milliseconds and P2 will be connecting for another 10 to 20 milliseconds. Then 20 to 30, N2 will be conducting, and 30 to 40, the again N1 will be conducting. So this is for the frequency of 25 hertz. Then next one, step down cycloconverter for the 12.5 hertz. The input frequency is 50 hertz, output frequency is 12.5 hertz. So the TS will be again 1 by 50, 20 milliseconds, and 1 by 12.5 hertz will be 80 milliseconds. So 40 milliseconds will be positive half, and 40 milliseconds will be of negative half cycle. So for 4 times of 10 milliseconds, we have to trigger the positive groups, and 4 into 10 milliseconds we have to trigger the negative groups. So here for 0 to 10, again P1 conducting, 10 to 20 P2 conducting, 20 to 30 again P1 conducting, 30 to 40 again it will be P2 conduction. So totally 40 milliseconds will comprises the positive half cycle. Then 40 to 50, N2 50 to 60, N1 60 to 70, N2 70 to 80, again N1. So this will be your negative half cycle. So here we can trigger it from either a 0, or we can trigger it from some alpha, that is the phase angle, that is 60 degree. By means of triggering sequence, we can vary the frequency. By means of varying the alpha, we can vary the output voltage. Output voltage can be varied by means of varying the alpha, and the triggering sequence can be varied by means to vary the frequency in the output. So here we can go for another frequency, that is 1 by 3. That is 1 by 3 means supply frequency 50 hertz, output frequency is 16.67 hertz. That is input time period 20 milliseconds. So 20 into 3, that is 60 milliseconds will be your output time period. So here for first one, P1 will be conducting, again P2, and again for 10 milliseconds P1, and again here it will be N2, and here N1, and again third one is N2. So for 10 milliseconds P1, for 20 milliseconds P2, and 20 to 30 milliseconds again P1, 30 to 40 N2, 40 to 50 N1, 50 to 60 again N2. So 30 milliseconds positive and another 30 milliseconds will be negative. So totally 60 milliseconds will be your output time period. So this thing we can realize in case of PSIM. So in PSIM we'll have first one, the output frequency of 25 hertz. So 25 hertz means we have to draw the circuit by center tapped configuration. So here we are having 4 SCRs, one center tapped transformer, input supply voltage, and load of resistance. First we can take. So for that we have to draw 4 SCRs, P1, N1, P2, N2, 4 SCRs. So this is one pair and another pair, and center tap transformer. This is your input voltage, and we have connecting the 10 ohms resistance. So the input voltage will be of magnitude 325 volt, root 2 into 230 225 to 325 volts, and again in load resistance 10 ohms, and we have to connect the gating block. So in each gating block we have to change the frequency as output frequency 25 hertz. So here we can have 0 to 90 degrees, and 90 to 180 P2 will be conducting, and 180 to 270 N2 will be conducting, then 270 to 360 again N1 will be conducting. So this is we have discussed over in the PPT. So 0 to 90 P1, 90 to 180 P2, 180 to 270 N2, 270 to 360 again N1, P1, P2 sequence, and again next sequence will be N2 and N1. So on running this, we will get the output like this. So 0 to 10 milliseconds, and 10 to 20 milliseconds, 20 to 30, 30 to 40, 20 milliseconds positive half cycle, another 20 milliseconds negative half cycle. So here P1, P2 will be conducting, next N2, N1 will be conducting. So this is your output voltage and this is your output current. So this will be of magnitude 325 volt, and this will be of magnitude 32.5, that 325 by 10, 32.5 amps. So here we are figuring it from the 0 point itself, that is 0 triggering angle. So here we can vary for different firing angles. Suppose we are taking the alpha as 30 degrees. So this is for varying the output voltage. We have varied the frequency. Now we are going to vary the output voltage. So 30 to 90, then 90 to 180 means, so we have to change it as 190 plus 30, 120 to 180. Then 180 to 270 means 180 plus 30, 210. Then 270 to 360, 270 plus 30, 300. So this will be your alpha firing angle of value 30 degrees. So if you run this means you will get the output like this, which having a delay of 30 degrees. So if we measure the voltage, we'll have the RMS value of voltage as different values, different for the different values of firing angles. If you are increasing the firing angle means, so the output voltage can be decreased. So by varying the sequence, we can vary the frequency. By varying the alpha, we can vary the output voltage. So this is for a frequency of 25 hertz. Similarly, we can go for the 12.5 hertz. So for 12.5 hertz, so here we can see, so this is your 12.5 hertz. So in 12.5 hertz, 12.5 hertz means 0, 10, 20, 30, 40. Again 50, 60, 70, and 80. 40 milliseconds for positive and 40 milliseconds for negative. So correspondingly it will be 180 degrees, and correspondingly it will be 360 degrees, since here this will be the positive half cycle of the output and this will be the negative half cycle of the output. So this will be 180. 180 degree means, so here also we can mark it as 180 degree means 0 degree. So 180 divided by 4, 4 half cycles. So it will be 45 degree, and 90 plus 45, 135, 135 to 180. So 0 to 45, P1 conducting, 45 to 90, P2 conducting, and 90 to 135 again P1 conducting, and 135 to 180 again P2 conducting. Then 180 plus 45 to 25. 225 plus 45. So 225 plus 45 will be 270. So 270 plus 45 will be 315. So 315 to 360. So here it will be N2, N1, again N2, N1. So it will be 4 switching points for each resistor. So P1 will conduct twice, that is 0 to 45 degrees, and 90 to 135 degrees. And again P2 will be conducting for twice in a first half cycle, that is P2 45 to 90 and 135 to 180. Similarly for N2 it will be 180 to 225 and 270 to 315. And for N1 225 to 270 and 315 to 360. So this will be your firing points, that is 4 points will be there. So in PSIM, while drawing for 12.5 Hz, we have to change all the frequency of the gating blocks as 12.5 Hz. So for each SCR we will have 4 switching points. So first one for P1 0 to 45, 90 to 135, and for P2 we will have 45 to 90, 135 to 180. That is 0 to 45 P1 conducting, 45 to 90 P2, 90 to 135, 90 to 135 again P1, 135 to 180 again P2. Similarly for negative half cycle, 180 to 225 N2, 225 to 270 N1, 270 to 315 N2, and again 315 to 360 again N1. So here all the SCRs will have 4 switching points, and on running this we will get 4 positive half cycle will comprises single positive half cycle in the output side, and again 4 negative half cycle will comprises single negative half cycle in the output side. So P1 P2 P1 P2 will be the triggering sequence. So here also N2 N1, again N2 N1 will be the negative side sequence. So here also we can try it for different values of firing angles. So similarly we can go for similarly for the frequency of 16.67 Hz, we can go for the frequency of 16.67 Hz of output frequency. So for that 30 milliseconds will be positive and 30 milliseconds will be negative. So P1, P2, P1, and again N2, N1, N2. So for this case, so for the 30 Hz, that is for the frequency of 16.67 Hz. So 30 milliseconds will be positive. So here 0 to 30 milliseconds will be positive. Then 30 to 60 milliseconds will be negative. Then 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. So here the conducting resistor are P1, P2, P1, and again N2, N1, again N2. So here this will be the positive half cycle and this will be your negative half cycle. So this will be in degrees correspondingly. This is 180 and this is 360 degrees. So this 180 degrees should be divided by 3. So each will be of 60 degrees. So 180 divided by 3 will be 60 degrees. So P1 will conduct from 0 to P1 will be conducting from 0 to 60 degrees. Then P2 will be conducting from 60 to 120 degrees, and again P1 will be conducting from 120 to 180 degrees. So here 0, 60, 120, 180. Similarly for negative half cycle, N2 will be conducting from 180 to 240, and again 240 plus 60, that is 300. Then 300 to 360 will be N2. So here N2 will be conducting from 180 to 240, again 300 to 360. N1 will be 240 to 360, 300. So this thing we can realize in case of PSIM, that is, so here we have to change the frequency as, so how much we have, 16.67 hertz. So 16.67 for all the gating blocks. So all the gating blocks we have to change it as 6.67, and here also 16.67, 16.67. So here P1 and N2 will have 4 switching points. So P1 will have 4 switching points. So the switching points are 0, 60, and again 120, 180. Then next one, P2 will have only two switching points. So that will be 60 to 120. The next one, N2, that is N2 will have 4 switching points, that is N2 will have 180 to 240, again 300 to 360. The next one, N1 will have only 2 switching points, so that will be of 240 to 300. So P1 4 switching points, 0, 60, 120, 180. Then P2 2 switching points, 60 to 120. Then next one, N2 will be 180, 240, 300, 360, and N1 240 to 300. So for this we will obtain 16.67 hertz. So 3 positive half cycle we are obtaining. Negative half cycle, I think there will be some mistake. That is N1, P1, P2, N2, N1, N2. This is P1, N2, N1, N2, P1, P2, N2, 4 switching points, 16.67, 180 to 240, 240 to 300, 300 to 360. And here 16.240 to 300, and we are getting positive half cycle as correct value, but negative 180 to 240, 240 to 300, then 300 to 360. So either we can run it for different cycles. That is 506. voltage, and output voltage will be only positive half cycle we are getting. In negative half cycle, N2 N2 will be 180 to 240. So here N2, that is N1, right? We have to change over here. So this will be negative half cycle means, so here N1 will be conducting. So N1 we have to change it as, that is, so here we have to change 2, and so this will be conducting for 182, 240 N1, 242, 300 N2, 300 to 360 again N1. So reverse that triggering points. That is 240 to 300. So here 4 switching points. That is 180 to 240, then 300 to 360. 4 switching points. So now we can apply, I think, yes, V in. First here there is input side, input voltage, and output voltage is like this, right? So we are obtaining negative half cycle as 3. The output current is not obtaining over here. The output current, so we have to obtaining the output current, input voltage, output voltage, and again input output current, right? So we are getting the output current like this. This will be of magnitude 325, and this will be of magnitude 32.5 volt, 5 amps. Thank you.